because he's upset. But... All right. All right. If the summation a to the n converge, absolutely. Guys, when limits of n approach infinity of a to the n plus 1 over a to the n is less than 1. So your next term divided by your original term. If it's less than 1, more likely the next term is going to be smaller. Does that make sense? If that's next term, it had to be in this particular order. Yeah, it's called ratio test. A ratio test. 2. If the series summation a to the n diverge when limits n approach infinity of a to the n plus 1 over a to the n greater than 0 or greater than 1, or limit n approach infinity of a to the n plus 1 over a to the n is equal to infinity. So either they greater than 1 or equal to infinity is diverge. Now sometimes you do get inconclusive cases, so the ratio test is inconclusive. When limits n approach infinity of a to the n plus 1 over a to the n is equal to 1.
Those absolute value signs.
So that's why they are converge. Not only converge, they converge absolutely rather than just converge. Does that make sense? Now, so now with this, you provide an extra powerful tool to conclude whether the situation converge or diverge. It seems like we have harder sign when we deal with factorials. So 2 to the n power over n factorial. So it seems like in this situation, we always have a hard time to feel like, hey, are they converge or diverge, because there is no specific test. And there was a geometric test, there was geometric series, there was a telescope, because you cannot take integral n factorial. Well, that one can be done with AST. So
No, you can do AST because you alternate, right? But
Yeah.
But no, it's not the sign that's alternating.
Yeah, so you would compare it.
How can you do AST? You can't do AST because it's not.
Not in this particular case, but one on the test, yes.
One of the tests was that exactly.
Yeah, so it's converge.
Nope, it's not.
Then it just becomes a geometric.
Can you guys let me talk? Thank you. I'm trying to get through it. Okay, so what you're gonna do is you're gonna list the summation. So you know that a to the n is equal to 2 to the n n factorial. And then what you're gonna do is limit n approach infinity of a to the n plus 1 over a to the n. So how do I write that? I write down 2 to the n plus 1 over n plus 1 factorial. I'm gonna divide this. Sorry, I'm gonna write down limit of 2 to the n over n factorial. Does that make sense? Now, what's nice, algebraically, they can start to simplify. It can simplify to n factorial over 2 to the n. Does that make sense? So that's equal to n approach infinity of 2 to the n times 2 over n plus 1 times n factorial. Does that make sense? Because you reduce by 1 times n factorial over 2 to the n.
Oh, what? Wait, n plus what? What is n? Can you speak to?
Yeah, he hasn't done that. He's just splitting up, so we can usually cancel it out.
So then you have limit n approach infinity of 2 to the n plus 1. And that's going to what? 0. Is that converge or diverge?
Converge.
Not only converge, it converge absolutely. It's absolute value. Mhm.
Yeah.
We did have.
We will talk about when after everybody taking the test. It can be done. The problem that question is alternating.
I mean, yeah, you could have put a name of one and then changed it to N and then it
Oh, because
goes
one
back
doesn't
forward,
matter.
I guess.
Yeah.
No,
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 it's not.
Times one with the last. Yeah.
Okay, so what you're gonna do, you're gonna try those two questions. See, are they diverge or converge? So the first question is gonna be n squared to the 2n plus 1 over 3 to the n. So it looks very complex. So for me, like ratio test is like most powerful tool for you to do. Now, sometimes the powerful tool is gonna get inconclusive, but this not the case. So that's the first situation. The second situation is the one that we always have problem since very beginning, is n equal to 1. So the only way to do this is like without showing like the maximum of each individual value. Like assuming that's maximum, remember beginning the sequence, we talk about n to the n over n factorial is, remember we did it this way. We did it like say it's 2 to the, we say that's a 4 to the 4th power over 4 times 3 times 2 times 1. Now since this one has a 1 lesser term, right? And then this one's going to be 4 times 4 times 4 times 4. And now here we push the maximum of each individual number. So this cancel out, and that's going to be n. Because that is less than, we can use a kind of compare, but this is actually a very hard way to visualize. But now we can use the, we can use a ratio test.
So which one are we answering?
Whoa. Julia, come back to me. You got 2 questions on the board. Remember, sometimes some test doesn't work. But those 2 cases, they all work. You had to be good at exponent rules. Dayton? There's 2 questions on the board.
Yeah.
The second case is a little bit harder. The second case is really hard to figure out. The second case is requires some creativity. You got your pencil. You have a Veda, you have her pencil. You come all the way here with a pencil. That's respectable. I won't trust Veda to hold your pencil though.
Let's go.
She's still gonna be the one that broke the pencil.
Excuse me, I'm gonna hit your back. So,
Yeah.
Veda, don't spill the pie. Do not spill the pie.
could you really stop with that?
And
it
then
happened more than a year ago. You're still on that.
and the next thing,
Leave me alone.
Veda spill the pill.
Bro, you really sound like my mom. Okay, you sound like my mom.
I have to. How's McDonald's? Apparently that's a hangout spot right now.
I'm not sure. You don't want to pay.
You
Yeah.
pay, you pay.
I actually run. She put in her code and everything. Yeah.
Wait, she's got a special code?
Free food.
Yeah.
Oh, it's free? Where did? Oh, that's fine.
Wait, how did you get free food at McDonald's?
It's like scamming people.
I know I could get free fries, medium fries, free.
The thing that I like, you got 20 pieces for 30. Right? That's how. And 2 free fries. I mean, medium fries.
That's nice.
When would you know that ratio test would not work?
When it's equal to, when it's greater than 1.
Or like,
Okay, so let's try it.
Wait. One.
Limits. N approach infinity of n plus 1 square times 2 to the n plus 1 plus 1, so n plus 2, right? Is that okay? 3 to the n plus 1. Is that okay? Divided by absolute value. Make sure you have absolute value. N squared 2 to the n plus 1 over 3 to the n. This is going to be let n approach infinity. N plus 1 squared times 2 to the n times 2 to the 2. All over 3 to the n times 3. Divided by 3 to the n over n squared times 2 to the n times 2. Anything I can cancel?
3 to the n.
2 to the n? 2 to the second? Can I? Oh, you can cancel that one out.
Oh.
Okay, so it'll be 2 over 3, right? Of n plus 1 square over n square. When limit n approach infinity.
2 over 3.
So it'll be just 2 over 3, but I will show a little bit more than that. So it'll be 2n squared plus 4n plus 2 over 3n squared divided by n squared top and bottom. So it'd be 2 over 3 is less than 1. So that means this converge, not only converge, it converge absolutely. Let's try the second one. The second one's a little bit harder. It requires a little bit thinking. N to the n over n factorial.
If it equals 0, what's our thoughts on 0?
If you go to 0, they say that.
It's still absolutely convergence.
If it's less than 1, it will converge.
Okay.
N plus 1 is our friend. Subtract 1 minus 1. That is your n.
Because this first part is equal to 0, right? Marcos, this is equal to 0. It's converged.
Okay.
Well, you
I
know,
forgot.
oh,
Yeah.
it's gonna be
Okay.
the same power. Yeah.
Okay, so this one is going to be limit n approach infinity n to the n plus 1 over n plus 1 factorial over n to the n over n factorial. Ratio test is my favorite test because mathematically it just makes sense. N approach infinity of n times n factorial over n plus 1 times n factorial times n factorial over n to the n. Why do I break that down? Because I can see the canceling. This gonna cancel like this. It's gonna cancel like this.
Like,
What?
something
Whoa,
wrong.
what? Isn't it n plus 1 at the
Is it n? Is it n plus 1? N?
No.
It's only n to the n plus 1. It's not n plus 1 to the n plus 1.
Yeah, I think it would be n plus 1 to n plus 1, right?
It's n plus 1 to the n.
Wait, hold on a second.
No, it's always
Isn't it n plus 1 to the n plus 1?
Did I make a mistake? Hold on, let me try to look. And oh, this one is n to the n, n to the 1. So this part is okay.
Oh, it's
M plus 1
It's,
times m factorial and m factorial. Wait, there's something I did it wrong?
Don't
Wait,
the
isn't it-
top left of your fraction.
isn't it
It could be n plus 1 to the power of n plus 1.
Oh, maybe.
Oh, I forgot. Yep, my bad. Thank you. We'll fix that part. Be like me. M plus 1 to the n plus 1. So be m plus 1 to the n times m plus 1, right?
yeah, you can get rid of that. N
So
plus
this cancel out, this cancel out, and then that's gonna be limit n approach infinity of m plus 1 to the n
Yeah.
to the n.
it would be technically 1 plus 1.
What? Oh.
Because I put it all in the n power.
Yeah, I mean, can you split it to 1 plus 1 over? I mean, you don't have to.
Yep. 1 plus 1 over n to the n. Do you remember what that is?
It's the.
E. It's on your competition test, remember?
Yes. And I think I got that wrong.
So E is greater than 1. So that means this is diverge. Because that's the definition of E.
It's just supposed to know that.
Yeah, we talked about this before.
I got all of them except for the I got 1 plus 1.
Y. So you have to do E on.
This is on your competition. Was E to the 500, I think?
I know.
e to the
But you don't have
100?
No, but what in there?
I think we
it's not long.
Yeah.
Yeah, that was
you have to look at it.
That's still.
no, because if it's just a so E by itself is 1 plus 1 over x to the power of x.
Yeah, because it was 100, right?
So that's
So E is
Yeah.
like the limit is x to the power of x, 1 plus 1 over x to the power of x.
If you want to.
1 plus 1. Yes.
Yes, x to the power of x. And then
They gave it if you want.
the question we had was 1 plus 1 over x to the power of 1 after that.
Okay, so let's try this one.
I
Yulia, come back to me. You kind of zone out every like 5 minutes.
It's a struggle to stay in reality.
I know, and I'm sick. I'm still here.
No, I think it's easier when you're sick because you're like, yeah, I'm sick.
You have an excuse.
What kind of logic is that shit?
I'm sick. Sick keeps you here because you don't always.
I'm sick. I want to get everybody sick.
No,
Also, I think I'm sure you're like incapable.
I don't think I'm incapable to take a day off. I actually went home and then take a nap and come back.
We assume.
I actually went home, take a
Yeah,
nap.
that's what we
It
assume.
was like 40 minutes nap. It was like powerful
What's the
nap.
point? Just now.
Right
It's us here.
after that. What period?
We took a power nap.
I went home, eat, and I take a nap, and I come back to get a coffee.
You're fast. You ate lunch, took a 40-minute nap, and had coffee. That's actually impressive.
Oh, like the way you said it.
I don't even know
Oh,
he did
no,
that. That would probably take me like 4 hours.
I'm like staring at the ceiling.
No, I was actually supposed to.
Yesterday, I sleep in the back for like 5 minutes.
But you were probably, I didn't know what everyone was doing. I turned around. What the heck is going on? Should I sleep
I feel like shit.
You should take like a day off. Rest.
If I take a day off, I'm like a day behind. So like,
Yeah, I know, that's funny. But no, you like recorded afterwards. Like, 5 minutes.
do you know that day I got surgery?
Yeah.
I still come in the morning for the first 2
Yeah, I
periods.
know. That's what we all moved respectfully.
And not only that, right afterward, I still teach an SAT class at 7 to 9. But like half, like Luke says, I was like half awake.
Yeah, see, I don't know if it's a good thing to create. Because like,
They tried that shit.
Oh,
at a certain point, you actually kind of need to like.
Why?
I mean,
But I guess if you're still able to, it's fine.
so interesting. When did you find out?
All right, come on. Next question. Thank you. So this one will be interesting.
Yeah, no, just.
So if I put an absolute value, that 91 to the end, it goes away. Does that make sense?
Oh, it's absolute value?
Yeah, that's n approach
Oh.
m approach 1 here, right? Absolute value of -1 to the n plus 1
Oh, it's just n approach.
over n plus 1 over n plus 2.
Wait, I thought it's n approaches infinity or 1?
And over of square root n over n plus 1. So what happened is this is -1 to the n plus 1. So the absolute value is going to make them go away. So limit n approach infinity of square root n plus 1 over n plus 2 times n plus 1 over square root n.
Oh.
Can I rewrite to limit n approach infinity of square root n plus 1? Actually, I'm just going to do this. I'm going to change that. Is that okay?
Wow. Okay, I was there, but then. Oh wait, the two. Put the two.
Oh, 2. Yeah, 2.
Wait,
But then.
oh, yeah. Oh, I see what you
If it goes to infinity, that becomes square root 1 times 1, right?
It's just n.
So it's inconclusive.
Is it conclusive? Inconclusive. Yeah, what's your question, Yuri?
He just applied the limit. divide volume is kind of slow moving.
You're gonna have to go up there if you point it out because I have no idea what you're saying.
N plus 1, and here n plus 1. Isn't it just n?
It is. Yeah, it
You
is.
just make
Yeah, that's just n. But it doesn't matter there. But
because
this,
it's the absolute value.
yeah, it's absolute value. It's gonna go away.
And what do you divide by?
So this is equal to 1. So if it is equal to 1, what does that mean? Inconclusive. So it's any other way I can take care of this situation. What? AST. So sometimes, yeah, you're gonna get using AST.
Would you do it of just the original function or of the new one? Like when?
How do we test for AST? Are they alternating? And let's check, right?
Yes, it is alternating.
And what else?
Limit and approximation it's equal to 0.
So it'll be a to the n plus 1 is less than a to the n. Is that true? Is that true? Let's say if I plug in n plus 1,
But which
No,
which
no.
equations?
for this equation.
Oh wait,
Okay,
No.
yeah.
no, because that's into
So
one
it
half.
was zero.
It's zero.
Safety scale on your conversion. It's zero. Oh, zero. It's zero. It's zero.
Is that true or no?
It's zero. It is zero.
Or you can try the decreasing, right?
One half.
You can see.
So how do I find decreasing?
You take a derivative. You can
Take a derivative. Okay, let's take a derivative.
Oh.
Let's just say f of x equal to square root x over x plus 1. If I take a derivative, it's going to be what? Low
Squared, no.
d high minus high d low over low low. Okay, so what I'm gonna do is I'm gonna factor out x to the negative half. So x to the negative half. If I factor out, what do I have? Maybe I'll factor out a 1/2 as well. Half. What do you have for the first term? X plus 1. And then what? Minus. This is a 1/2, right? Two x, good, over x plus 1 squared. So the bottom part's not issue. So the top part is negative x plus 1. And this is square root of x and 2 and 1. And that's going to be x plus 1 to the square. So is that always increasing? So x is going to be,
Yeah, it goes deep.
it start at 1, right? So at 1, it start at 1, it's going to be everything, it's going to be negative 1 plus 1. But when x is greater than 1, it's always decreasing. So we got decreasing, we got alternating, and we have to say, well, what happened when limit n approach infinity of square root x over x plus 1? Is that equal to what? 0. So that's true. This is true. Alternating is true. So AST says it's converge. So can sometimes you have to go back to AST? Yeah.
Conventional or yeah. Now you gotta prove that.
Then yeah, for me like it's converge. But yeah, you can you can look at it as converge or diverge. How do I look for that? Let me see. it possible to see? It's probably conditional because it'll be you compare to the 1 over n 1 over n 1 over square root of n, and that's gonna be diverge. So yes, it's conditional converge. Do you know what I'm saying? And you can use limit comparison test. Limit comparison test is going to be compared to m approaching infinity of square root x over x plus 1 to the x to the 1/2. So that is going to be x over x plus 1. Wait, x to the, hold on a second. Am I tripping? I compare to 1 over, wait, hold on a second. Let's compare to 1 over, compare 1 to over square root x. X approach infinity of x over x plus 1. So that's equal to 0. So positive. Wait, is this a positive or not? It's 1. I can't divide it. Yeah, divided by x. Yeah, sorry. So that's equal to 1. Sorry, my bad. So therefore, it's gonna be converged, conditional, because we do a LCT, and if an LCT is compared to 1 over n, that's a diverge. So therefore, this one's diverge. So it will be a conditional converge. I'm sorry, my brain's not really working, but so it's every other day. I know. I might wait. Divided by x. What am I gonna get?
Yeah, you probably need to like.
Maybe it's time to take a day off.
Yeah, honestly.
So at least say the name.
Anything is not.
You did?
Bro. And I typed them in my phone.
No, but like in the names.
Yeah.
No, no.
Where are your kids?
Okay, so that's a ratio test. So we just finished learning all the different tests. Now, why do we do this last one? It's because ratio test data, we're going to talk about the radius of convergence. So we need to use ratio test again.
Yes, you know what?
The radius?
Ratio test.
They said the radius of convergence.
Oh my God.
Yeah, I think it's time for a day off. Mental health day tomorrow?
Tomorrow's Wednesday, right?
Maybe you can do it on Thursday.
Oh, yeah.
I'll take a mental health day too.
Mental health Thursday.
Yeah, it was like dancing.
I'm going to be a day behind. I don't like to be a day behind.
Are we a day behind?
We're not a day behind.
So annoying.
AST. Tried it. It works to do converge. But then you also test have to value to make sure it's conditional. So try the up to value. And to do that one, you need to do limit converge. And you figure out what that means diverge, so it's conditional.
You don't look alright, Mr.
Huh?
You don't look good.
Huh?
Do it.
Oh, yesterday I feel like shit. I was laying down.
Oh, you left for a lot. You need a draft. Way too long.
The class is over.
What does that mean, bro?
There's people walking away. Oh, there's people walking away.
What does that mean?
My brain's not working.
Need something to say?
Mark, what's the green guy? I think it means something with
My
Spanish.
bad, bro.
I know what's happening.
Pretty sure I.
What is what mean?
Whatever you said.
That means private parts.
He does?
Oh, what do you mean?
It's Spanish, right?
Bro, I know.
Green guy? Private parts is Spanish.
Okay, what?
Don't feel bad. It's all good.
Yeah, that's my.
I feel like shit.